Hello again and welcome to Week 2 recap for the Opus Magnum 2020 tournament. The puzzle for Week 2, Amalgamated Gold Ring, has inputs that are metal and quicksilver, two different types of metal, the iron and the lead, and an output that is a ring with 2 gold and 4 quicksilver. Whereas the first puzzle, there was something relatively simple to be said about how to get from inputs to outputs. This one, it's not trivial. You have to figure out what's the most efficient route to turn these objects into this one, given that you are given both the glyph of projection and the glyph of purification. That means that you can combine 2 metals of the same type to increase the tier of the metal by 1, or you can combine the metal with a quicksilver to increase the tier by 1, no matter what tier the metal is. The 2 categories to solve this for were area and throughput. Throughput is an interesting metric to try to define, but I found a reasonably strong definition for it that relied on number of cycles between outputs in the infinite limit. Which means if you're trying to go at max throughput, you are outputting products as often as possible, but it doesn't punish you for having a long lead-up time to that first output. Now, before we dive into what was submitted, I want to go over just a couple of general concepts related to this purification, a combination of purification and projection. I'll use one input for now just so that it's a little simpler to think about, and I don't necessarily care about doing things efficiently, so I'm going to just throw down some components that are doing possibly not the smartest things. First, consider if we were to take a copper made in this way and project it into a silver. We've used 2 of this input to make a single silver. We have nothing left over, everything's been used up, but this isn't optimally efficient. If we instead were to use the 2 iron and purify them together into a copper, and then afterwards use this projection glyph, one of the 2 leftover quicksilvers, to make this into a silver, we would have a silver and a leftover quicksilver. We could make gold directly, also from 2 of these inputs. So there's clearly ways to be wasteful here that do not come from throwing things into a disposal glyph. I provide a disposal glyph in case people want to figure out solutions, have a little bit left over, and be wasteful. But the principle that was different between the one where we got a single silver out of this and the one where we had the option to get an entire gold is that you should always be purifying metals using their equivalents first, saving up all the quicksilver you can to use on the highest value metals you can. Because the value of a quicksilver is effectively equal to whatever it's used on. If you want to use a quicksilver on a lead, that is the lowest value cost use of quicksilver. If you want to use it on a silver, that's the highest possible value. So the fact that there are quicksilvers in the output means that the output could also be considered to be 2 of the metal that's 2 past gold. If, for example, we call gold the 6th metal, where lead is 1, and then 2, 3, 4, 5, 6 gets you to gold, you could consider this 2 of metal 8, because the thought is that you would always be using these quicksilvers at their highest value to promote the gold past itself twice, to get this output looking like metal 8, and then the inputs are metals 1 and a quicksilver and 3 and a quicksilver. Just a way that I like to think about this puzzle for solving. So then, what does an optimal efficiency route look like if we have to try to calculate how to always optimize for the best possible gold, or the best possible usage of these quicksilvers? Well, first let's think about using only one input because that's slightly easier. What is the most efficient output path using this one input? If you write it down on paper, you can use 20 of these to make 3 of these. The fact that 20 to 3 is the best possible means that a ratio of 7 of these to 1 of these is the simplest option that is using only one output per loop, and 8 of these to 1 of these is an attractive option if you want to break this in half and build a gold and 2 quicksilvers each. You can use 4 to build half of an output, meaning 8 to build a full output. We'll see solutions in the area category to use only one input and make either of those options. All three of them happen. Using both inputs, the math is extremely messy. There is a quick calculation that I will flash on the screen at some point. And that calculation leads to the output conclusion that you can use 80 of each of these inputs to make 21 of this output. And that is optimum efficiency. That's also extremely close to using 4 of each of these inputs to make 1 of these outputs. So that's nearly optimum efficiency and is designed to be a very attractive option for people. And you'll see solutions in the throughput category to use either of those ratios. So now let's dive into solutions. First, I'll skip over anyone who is designing a solution for not the area category and start with the person whose intention for their solution was area. This uses just the iron and the quicksilver input, so we can see that they're using the best case choice of 20 to 3, or in this case, they're using the build half of an output, where they have now made 2 quicksilvers and a gold, using 4 of these inputs, and then build the next half using the other 4, leading to an 8-to-1 ratio for the output. It also takes 37 area. All these equilibrium hexes, the fact that there are 3 bonders being used, and the fact that each piston has quite a bit of extra space for itself. This one comes with 2 tracks, this one comes with 3, add up to a lot of extra wasted area. However, this is demonstrating quite well the fact that you can solve it without an extra glyph of disposal if you make sure to have a path that eliminates all the quicksilver, even if it's done wastefully. For example, you can see you're purifying silver after projecting copper. That is intrinsically wasteful, but waste isn't a problem if you're just trying to stay in a small area. It is slightly slower. It means that you'll spend extra cycles if you have to grab these inputs more often. But it is a good solution nonetheless. It stays small and it does the problem. So once again, because these solutions run kind of long, I'm going to start using Alt-click to get through to the end of them faster. With 855 cycles at 37 area. Next up on area is Aberration, also at 37, but slightly faster. And Aberration decided not to use any purification glyph, instead using all the quicksilver that they could off of these 2 inputs and throwing away all the extra metal. This makes the problem quite a bit simpler to solve, because if you have the option to just throw things away, throwing things away is easy. You don't have to work out any of the purification math of making sure you don't have stuff left over after you've created an output. But it does mean that you have to place this honking glyph down on your board, and it uses up quite a bit of area. But among the 37 area entrants, using as little area as possible wasn't quite the intention. They were trying to optimize for area without necessarily designing a solution around hitting min area. So at 438 cycles, this one beats the other solution on the tiebreaker, which was cycles. Next on area is From Above, with 28 area. So it's a significant improvement already over the 2 that we watched just now. Not all the area is used up when the solution starts. It's used up during swings when creating the output. But at this point, they've used all of 28 area. They're using both of the inputs, and we'll see how much of each input they use. So their initial movement is to build a single iron, and then combine it with a new iron, leaving 1 quicksilver spare. And they repeat this a second time. In so doing, they've left themselves a silver and 2 quicksilver, and they purify it into a gold. Because now they're not in the exact same state that their machine was when they first made this output, they have to do something slightly different, but they find a more efficient way to generate a single iron, and they end up exactly where they started. Given that I don't think they made a non-looping solution, they find a way to become clean before it's all the way over. I don't know how. Oh, I see. Yeah, rather than use a single quicksilver to make that silver into a gold and leave a metal waste, they build a single silver to turn the silver into a gold out of 2 of this input. So it's creative problem solving in the fact that they don't want to have extra metals left over on the board, they want their solution to loop, but it is extremely inefficient in how it's using the inputs, because clearly one Quicksilver did the same job as two of this entire input if you were to allow wastefulness. But it's important to not have waste in an area solution. Additionally, using both of the inputs is generally a slower and higher area option, but again, this isn't the minimum area. This is a solution that happens to be optimized for area and is wasteless. And so for that, it's good. I think this one runs for so long, I'm not going to bother getting into the end. We're already well over 1200 cycles, but this is from above solution and it is good. Onward to Peen Locket. Peen Locket had mentioned something early on about having not ever really solved the pure projection math well. So their solution does not use the purification glyph. They, similar to Aberration before, simply throw away a lot of extra metal. They just do so in a more area efficient way, only using one of the inputs and keeping the pistons and all the work inside of a small footprint. So this hits 26 area, and it does so quite a bit faster than some of the previous solutions due to throwing stuff into the disposal being quite a fast option for solving the puzzle. But yeah, 26 area and 458 cycles. They build the ring like this with only projection and lots of waste thrown away. 26 area. Next is Kyujin Desu, who hits 24 area. This is another pure projection solution where it's using both the purification and the projection glyphs and generating half of an input plus an extra Quicksilver. So at this point, they're not able to repeat that same action to get to the second part of their solution, so they use 7 inputs to create one output. This is using the 7-to-1 ratio, which is more efficient, of course, than the 8-to-1. The first set of 4 inputs creates this over half of a ring, and then the next 3 inputs can create a gold to finish off, plus 1 more Quicksilver that comes out from the first. So yeah, a 7-to-1 ratio makes it quite fast, but it does use up some extra area because of the way the ring is assembled. It's not well covered by other glyphs. So all of the building of the ring has to happen in this extra spot where it swings off into the other pieces necessarily. The best solutions would end up placing something around this ring so that the process of building the output doesn't swing into area that isn't already used by glyphs. However, I consider this a very good approach to the puzzle. It uses the 7-to-1 ratio, which is pretty exciting, and it finishes in 721 cycles at 24 area. Up next we have Flappy. Flappy gets 23 area using a single piston on 3 tracks and organization that is well designed around this track. By the looks of it, this solution will combine 2 silvers to make a gold, meaning that it is assigning 1/2 output per 4 of this input, which means that it is easy to make a looping output from it. It will not have any problems with extra waste left over when the solution is over. It's using 8 inputs to make 1 output. And the assembly only uses this 1 extra hex, so they do a much better job than the previous solution of keeping all of the assembly process, the steps that the ring passes through in the process of bonding together, from spilling out onto other parts of their solution. There are still a couple of wasted hexes, so you can imagine getting fewer area by 2 just by filling these 2 with something meaningful and removing it from out here. There's also the option to remove one of these track. I would say that it's clearly not possible to use no track on the solution because it's not possible for one piston to reach all 3 pieces of this glyph, and you need to have single atoms on each of them, so you can't use the indirect tricks we talked about in the previous puzzle. But there, is still some area wasted, but here we're at the point where the area numbers are getting down very low, and so it's good to see that approaches to this puzzle that are optimized for area are taking in the initial layout and trying to design smartly around an initial layout that makes a good sense for low area. Up next, we have a solution that surprised me quite a bit. So this one was 23 area. Hutobi's solution was also 23 area, but used the disposal. I had tried to design a glyph of disposal area solution at one point when betting this puzzle, and I thought 24 might have been the minimum, but I didn't place the bonder in the same way that they did, so I ended up being unnecessarily wasteful. They use an indirect glyph of projection here, which is probably the biggest thing that I overlooked when I was trying to make my 23 area. And the fact that it gets to be indirect means they don't have to place it in a different position so that the piston has to reach the side of it, and that means that they can use this particular layout, which allows the building the ring process to spill up only onto tiles that are already taken up by this output, or by the disposal glyph. So yeah, by being wasteful, they are going to unnecessarily use up all these extra hexes for this. But this is as small as you can imagine a solution possibly getting using this disposal glyph, because you can't put anything meaningfully in the center of the ring. Putting an arm there means that it could never pull the output towards itself from any direction, because it'll have an atom overlapping with it right beforehand. So I was very impressed by this solution. Unfortunately, despite the name being possibly perfect, I feel like Utobi probably overlooks the idea that a purification glyph is a much more area economical way of handling the fact that your puzzle is going to be producing more metal than you need if you're using in this only the Quicksilver. So, despite not solving any of the purification math here in this puzzle, using only the glyph of purification, hitting 23 area is quite impressive. And at 1407 cycles, it slightly edges out the previous solution from Flappy, which was at 1500 cycles. Up next on area, we have Ancaligor, who also submitted a 23 area solution. Interestingly, there are 3 single arms and 1 multi-bonder here. No tracks under the arms, and one of these isn't even a piston. So, a very different approach to hitting low area that happens to have the exact same area count as the glyph of disposal minimum otherwise solution we just looked at. And they purify all the way up to silver. They build more than half of an output. And so their second round uses only 3 of these inputs to build 1 gold, 1 spare Quicksilver, and finish the output. So this is another 7-to-1 solution. It doesn't take up any extra space outside of its footprint while assembling the ring, but it does use a multi-bonder specifically for these 2 directions of bonding. So there's a spot down at the bottom that is used only because the multi-bonder can't be placed with only 3 of its hexes. You need the 4th when you put it on the board. So yeah, very neat 7-to-1 solution, and I think the only area solution to use a multi-bonder. That's pretty neat. And due to having 3 arms working in parallel, it's faster than either of the previous 2 solutions. So among the 23 area solutions, this one wins on a cycles tiebreak using... Wait for it. It's a little over 1,000, but it's far less than 1,400 cycles in total. Yeah, 1113. All right, up next is Mattermonkey's area solution. That's a throughput solution. That's Monster Racer. There we go. Mattermonkey with 22 area. So this was the smallest solution to use both inputs. And unfortunately, Mattermonkey had told me at one point throughout the week that he has not been more confident in the past about any other puzzle that it was optimal area. Which is a sad oversight to have only looked at solutions to creating this output, which employ both of these inputs, and not looking at solutions that employ only the iron and Quicksilver input. It's also entirely possible to solve this using only the lead Quicksilver input, but everyone who decided they wanted to only use one input used the one with the higher value coming in, because the iron is a higher value metal than lead. But regardless, we get to see an approach that is going to be used in a few of the throughput solutions as well, in which 4 of this input is used to make a gold with an extra Quicksilver, and then 4 of this input, same as into the 7-1 solutions, is used to make a gold with 3 extra Quicksilver. It's also interesting to me that a bond that needs to be broken is created here for the purpose of storing something that neither of the arms could reach on their own. This hex in the middle of the ring, both of these arms are at a strange knight's move away, so they can't place a single atom there, but you can place something there if it's bonded to something you can't reach. The fact that a debonder is a necessary part of the solution anyway, because both of these inputs come bonded, means that you can get to the output and you can get to this broken off piece and fix any of the intermediate steps that you make that are not necessarily part of the desired output. So yeah, 4 of these and 4 of these also suffices to make an output. It's just less area efficient to have to place all 4 atoms of input when you can get away with using only 2. So it's a unique approach, but yeah, sorry Mattermonkey, this is not in fact area optimal due to the extra input and all. But among the 22 area solutions, which as we can see beat everything we've seen in the past, This one at 1556 cycles is next followed by Chickens in the Attic, who also uses 22 area, but slightly faster at 915 cycles. So I talked previously about looking at a solution and figuring out what area it is wasting. This one does not have any wasted area around this output because it is able to create the output using all the swings necessary to get from this bonder to the output, using space that's already taken by this purification glyph, and this quicksilver projection glyph. Those pivots here are very clean. The 2-length pivot that goes from here to here just passes over output tiles already and uses these 2 tiles here. So there's nothing used outside of the footprint. The only wasted area in the solution is the fact that both of these pistons have 2 tiles to themselves. And it's 4 tiles of manipulators plus 18 tiles of necessary pieces you can't solve the puzzle without. Plus one tile if it's literally impossible to put something meaningfully here. And so, as an aesthetic choice, basically everyone decided that inside of the middle of the ring is where their origin of their coordinate system lives, just for that aesthetic goodness. It's also interesting to me that this solution has no instructions until you get quite a ways down into the instruction tape. This is likely because it was optimized somewhere in the beginning, and instead of moving everything to the left, they just started moving the start of it further and further to the right. Which is not a bad idea. It makes it slightly easier to compress the solution's instruction tape when you find out speedups. But it was funny for me to look at the solution and be like, wait, where are all the instructions? In terms of the route that this solution takes, it does look like it is purifying all the way up to silver, and then combining all the quicksilver in the end for gold. Oh, no, it's still using... This is a slightly different way of using 8 to 1, I believe. It's equivalently wasteful to the other 8 to 1s due to being 8 to 1, but its first act is to project into a single copper and purify into a second copper, which leaves you still with a half of an output but with an extra iron. And then using another 3 inputs. Okay, no, it is a 7 to 1. I believe it is a 7 to 1. So that's an improvement, yeah. It's a 7 to 1 that's doing the half that is traditionally second first. Maybe it should be the one establishing the tradition and everyone else is doing it backwards. Right, next up, we have Alerka. Alerka is the first of the 21 area submissions. This one is using the minimum amount of space for arm and track, due to the fact that you definitely need one piece of track to be able to reach all points of this glyph, but otherwise you're covered. You can hit everything else in this entire layout using this single arm and 2 tracks. The reason it's 21 and not the optimum of 20 is the fact that during the assembly process, this hex right here does get run. And that's because this output is placed at the edge of the solution and there is not enough glyph coverage around it to cause it to be able to not take up an extra space while it is being assembled. Also notable with the solution, though, is the fact that I alt-clicked once here and it's built 3 outputs. This is the first solution to use the optimum 20 to 3 output efficiency route. So you can see at the beginning, it has no extra tiles on the board because that's how everything starts the solution. It uses the first 4 inputs to create this slightly better than average half of a ring, and then it finishes it with an extra iron on the board. Despite the wasted area here, it now has to work with an extra iron on the board. So the second time it creates half of an input, or half of an output, it has an extra iron on the board still. And then when finishing this second half, it has 2 extra irons on the board. It turns them into a copper, and for the third output that it creates, and the 6th and all multiples of 3, it's able to use that copper effectively in speeding up and generating exactly half of an input with an extra iron. And from this point, you can actually finish out the puzzle. So the first one takes 7 inputs, the second one takes 7 inputs, the third one takes only 6 inputs for a 20 to 3 ratio. So optimally efficient in its use of all the lifts, but not optimally efficient in its use of area, given that this is an area category Alerka got 21 area at optimal cycles, but we will see Alerka return later with a very good throughput solution. Clearly they understand how to use the glyphs most efficiently. The next 21 area solution is Tweedledee. At 1159 cycles, it's slightly faster than Alerka's, largely due to using 2 pistons instead of 1 piston on a track. It is a 1 output per cycle, or per tape loop, and it is one that builds with 2 silvers purified to a gold. So this is building 1/2 of an output per 4 inputs. It's an 8-to-1 route, uses 2 pistons, takes 21 area, using this extra hex to assemble because, again, the output is at the very edge of the solution. There's not enough glyph coverage around it to prevent it from spilling out onto 1 extra area. The work of 2 pistons is always the better option if it's available in an area cycle solution. Usually the advantage that a piston on a track gives you over 2 pistons is that you can move the piston out of the way of certain large molecules that you might be building in the process, but here this ring isn't particularly large or clunky, so I think for area there is no reason that you shouldn't be using 2 pistons for cycles if you can find a layout that admits 2 pistons. Good job, Tweedledee. Up next, Fiondeer also used 21 area with only 717 cycles. In this case, I think Fiondeer might have realized that the glyph coverage around this causes 21 to be important and decided to use 21 intentionally, because not finding a 20 area layout. There's also the problem that was identified in previous solutions where there's a spare iron left over on the board, but Fiondeer, again, using perfect purification efficiency, builds 3 outputs out of 20 inputs, using 7, then 7, then 6. So their solution's similar to Alerka's, does optimal purification math here, which is good for cycles. And the fact that they're using 2 pistons is also good for cycles. And all of the spins that assemble the output happen inside of this. The only thing that is an extra area wasted is the fact that this piston's on 2 track instead of by itself. 21 area, 717 cycles for Fiondeer. Now we get to the optimum area solutions. The slowest of these is Monster Racer at 20 area, 2000 plus cycles. This is a single piston on 2 tracks, so it's going to be slightly slower than all of the 2 piston solutions, but it is the first one that we are to see that will hit minimum area. There's good glyph coverage around this output so that the process of building it doesn't spill out onto extra tiles. The process that Monster Racer chooses to use to actually build the output is to purify a gold, attach to it 3 quicksilver. I believe the structure has taken 6 inputs to make. I might be wrong. That's 2. Oof. I remember the issue that Monster Racer had with his solution now. He ended up with an extra iron, but did not use optimal purification math to land there. He took more than the 7 inputs to get to 1 output plus 1 iron. After creating the second output, the waste that is left over for his solution is, again, a single iron. So instead of trying to find a ratio that got to an optimal purification math, he always has 1 iron left over after he builds an output. And since that's not the initial state of the solution, his solution cannot loop. So this is 2000 cycle solution, and those 2000 cycles were all placed using repeats or manual repeats, because you don't get to use a repeat if you're not in the same state your solution started in. So Monster Racer created this optimal area solution with 2000 cycles, but he had to place all those cycles by hand because the final state of his solution after dropping an output is not repeatable. I wasn't able to tell him as a host that there's a better way. I let him work through this problem himself, but I am somewhat sorry for the pain that this caused. As a learning experience, Monster Racer, we will go through other solutions after this that also hit 20 area without the same pitfalls that yours has. Still, for hitting 20 area, Monster Racer was awarded with full category points, and rank points were behind everyone else who also got 20 area. This was 16th of 31 submissions. No, it was, never mind, those first 2 columns are header columns. This was 14th of 29 submissions, and it earned him 7.8 points. Axel had also an area solution with 20 area, also using a piston with 2 track, so not quite as fast. let's see what route Axel chooses to use. The layout does not allow Axel to immediately move things onto this purification glyph without having already let go, grabbed the Quicksilver, gotten it out of the way. Also, by combining 2 silvers to make a gold, they have chosen the 4 inputs to half an output route, meaning it's 8-to-1. So this is a standard 8-to-1, not using any extra space, but not necessarily designing the layout such that it was fastest. Just, I think this might have been the layout which was most promising to be able to be solved at 20 area to Axel without much consideration of how can I do this as fast as possible at 20 areas. So again, it's full category points, but is not as high as possible on the tiebreaker for cycles. Nevertheless, I like any of the 20 solutions, so very, very good job. The next, I'll skip the rest of this one because again, it's going to take a long time. It's 1800 cycles and it doesn't let me click once and skip to the end. Severe has another 20 area solve. This one's a little odd in that it has pieces sitting way out here, but it has a very familiar feature to my own solution here, in that it uses an arm for coverage of this output instead of a glyph. By choosing to put an arm here, there's not as much ability for this input to be available to both, and it causes the solution to be kind of bottlenecked by arm 1. All the pivots that have to happen here instead of 1 tile over because the arm is only covering 1 tile instead of the second tile. Yeah, having seen some of the better solutions that come in after my own, I can see the solution is inefficient, but it is exactly the same decisions that I chose to make, where an arm covers this glyph and the input is set off weirdly to the side with a gap in between it and the rest of the solution. With 2 arms, an 8-to-1 output ratio, this solution takes 1,351 cycles, and it's at 20 areas, so it's again full category points. RP0 is the next 20, and this was quite the ridiculous choice. There's an indirect bonder over here. Neither of the pistons can reach this part of the bonder, but all the bonds are being made to something that is already bonded to a Quicksilver, allowing it to avoid needing to reach that tile. And then there's also this large amount of input suppression going on so that all these pieces can pass over this tile. It's using the input as glyph coverage, and that always requires some suppression. I didn't look perfectly yet. This might be a 7-to-1 ratio, but I don't think it can be because it has to use so many Quicksilver on this first input because it's using an iron bonded to a Quicksilver for that very first piece. I've skipped the part where I can start counting. This is one of the most unique solutions that I've received because it has to use the input and input suppression to prevent there being extra spillover when it's assembling the product. It's very creative. It's not very efficient, but it's clever and I love it. Despite having 2 arms that are both really well positioned to solve this problem, they have to do so much extra, what word do I even want to use, monkey business, to be able to get the output built. It's also hard to just count how many times something moves off the input, because sometimes the thing moving off the input is the atom which is used to suppress it. So 1, 2, 3, 4, 5, 6, 7, 8. Yeah, there's 8 inputs used, but in a very different ratio than the standard 8-to-1 where you build half and then you build the other half. Next among the 20 area solutions is SGS. Where is SGS? There we go. Another 2 arms with coverage of the output made of glyphs. Imagine that. Chooses to purify the first copper, turn that into a silver, turn that into a single gold with a single Quicksilver. I believe they probably found the 7-to-1 approach, realized that if you want to store only 2 instead of 4 pieces, then it's easier to get the rest of the solution working. So yeah, their second piece is using 4 of these inputs to make a gold and 3 Quicksilver, so they're using a 7-to-1 output, but they're doing it in the same way as Chickens to the Attic did, where they do the part which leaves you inefficient first, instead of inefficiency when you already have 4 atoms on the board trying to work around them. That probably is, in fact, a smart cycles decision. And for SGS, it caused them to have a solution which completes in a little over 1,000 cycles. At 1,000 and, okay, not a little, it's 1,099. A little under 1,100 cycles, perhaps. The next step on the 20 area solutions is by Panic. I'll just go ahead and skip to that one. The area solutions don't have as much diversity, so it's not necessary to watch all through 6 loops of all of them. Okay, so it's interesting to me that Panic was able to hit sub 1,000 cycles at 955 using only a single arm on a track. I had viewed using 2 pistons as the necessity for a good area cycle solution, and it still is for the best levels, but Panic has made a very good solution, and you can see it's using this extra iron output. So this is a 20 inputs to 3 output solution using a single arm on a track that is able to achieve under 1,000 cycles. There's glyph coverage and input coverage, but the input isn't going to be suppressed at any point. This is probably only here because that's the most convenient way to get onto the debonder while holding onto the metal, because you want to be holding onto the metal. It has to move specifically onto purification before you need to do anything with the Quicksilver if you're using everything optimally. So yeah, Panic with an optimal solution in terms of efficiency and at lowest area. It's 20 and under 1,000 cycles. Also, I believe that was the entire instruction tape programmed out from start to finish, which isn't necessary because you can create a 3 output tape. But if there's some squeezes to be done to make sure that you don't have waste sitting on the board after your final output, use things a little bit more efficiently there. It makes sense for people to use oh no, it might have actually looped at 3 and I just clicked it again absentmindedly. Regardless, this is a 20 to 3 and that's very cool to see. And at the 110 gold, it was the only single arm 20 area solution to get sub 1,000 cycles. So if this was cost area cycles instead of cost cycles area, Panic would have been the current winner, but instead now we get to look at all the faster solutions at 20. Brother Mojo comes first. This one's called 2 Arms V2. Evidently Brother Mojo first had found one with single arm on 20 and decided, no, let's use 2 arms to go faster. And faster it does go. So uses the Quicksilver on a copper here. Ends up with an extra copper after 4 inputs. And then extra lead here. Perfect. Okay. I believe this is a 20 to 3 solution as well. Yeah, it has an extra copper on the board after 1 output, or extra iron after 1, extra copper after 2, and then nothing extra after 3. And because Arm 2 is taking care of so much of the final delivery, Arm 1 gets to do a lot of the prep work, while Arm 2 is still finishing up its work. It looks like an X instruction was used to prevent things from starting too early, so it's optimized to place this X instruction as early as was reasonable, and still allow Arm 1 to get working on the second half. At 912 cycles, this is a very, very efficient machine, and it's using the maximum pure ejection efficiency, so good job, Brother Mojo. At 912 cycles, it was narrowly beaten by my trial solution of... my trial solution is not in this list. I had it at 200. I had it at 907, and it looked a lot like Severe's. I'm not going to bother showing it. It's fine. I would have to go through file systems and add my solution back to this list, and I don't need to do that. Mr. Puzzle also had a 20 area, and it was much faster at 822. Another layout that puts the input kind of out of the reach of the rest of one of the arms, but there's a lot of very efficient interplay between the 2 arms. They hand things off well. There's no spillover because the glyphs cover the output well. And again, I think one of the best decisions that this solution makes is grabbing the metal of the input and being able to continue moving it off the debonder without any adjustments made to the Quicksilver. That's a very good movement to make for efficiency. Lastly, let's look at what happens with the outputs. What is this extra Quicksilver on the board? Okay, yeah, I have to figure out this ratio. Having extra Quicksilver on the board when you make an output is a sign of something. So there's 2 extra Quicksilver after the first output. There's 1 after the second output. And there's none after the third. Okay, I'm used to seeing 20 to 3 look like an extra iron, an extra copper, and then nothing. but it's entirely possible to put 7 inputs into the first output, and 7 and 6, and get Quicksilver out as a... Now how could this work? It must be 866 and not 776. Well, very cool. I never looked at this very thoroughly before, but Mr. Puzzle, you have found a different way to get 20 to 3 than most of the other competitors, and it's very cool. Up next we have Brooke Eos. Now this layout is going to return later. This is evidently the slickest layout you can design for this solution. Both of the arms have clear access to this input. If you want to grab it by the metal, you'll have to grab it with arm 2, but the amount of clean handoff locations and ease of making this input-output combination make this layout is a very effective one for hitting 20 area and going fast with it. Now Brookie here uses the 8-to-1, building half of an input and then building the second half. Let's see if I'm wrong about this actually, because I see a silver on the board. Nope, 2 silvers combined to a gold. So yeah, this is 8-to-1. So 8-to-1, but the slickest layout that you can choose, as far as I'm aware, makes Brookie's solution take 738 cycles. So we're getting up there. We're getting to the fast solutions. There are 4 people left to beat Brookie. So at 738 and 20, we can see that next Shadow Cluster was able to design a 707 cycle solution at 20 area with basically the exact same layout. I think the orientation of this glyph is different. I believe Brookie's had the output side closest to arm 2. But otherwise, this is just an upside down version of the same solution. The pure projection ratio that Shadow Cluster chooses to use is also 8-to-1. The choice to pivot into the output is better than extending the piston to get into the output, because it allows it to return to the rest. Well, it does depend on the rest position of the piston, but in this case, yes, allowing it to return to its rest position faster saves, I think, a good number of the cycles. And the others might just be a strange consequence of having the purification glyph at a slightly different angle. Yeah, Shadow Cluster's 8-to-1 solution on 20 area, using this same slick layout, gets Shadow Cluster 4th place. Volomni has 3rd place with, where the heck is R in the alphabet? 623 cycles. Not the exact same layout, switching the location of the bonder with the location of the calcifier, but still putting the input in a way that both of the arms can easily reach it, and one of them can grab it on the metal and put it immediately on the debonder. What pure projection ratio does Volomni choose? I'll have to count inputs from here. So immediately starts off purifying into a copper that looks like a 7-to-1. I said purifying, I mean projecting into a copper. So yeah, this is a 7-to-1, which is more input efficient than the 8-to-1s, but still is only building 1 output per loop. The 2 solutions which beat this are both using the 20-to-3, and they're very, very slick. So at 623 cycles, Volomni takes 3rd place. Penta Pig made the 2nd fastest of the 20 area solutions at 541 cycles. And this one is not the same. It's not the same layout as the ones that we've seen before, or the one that we will see take first. Penta Pig's layout allows only one of the arms to grab the input, but it does so with a very easy swing that goes over pieces of the puzzle. So, given what it's doing, it is able to hit 541 cycles with this layout, which makes me think that this was probably also a very attractive layout. I don't know if each of these layouts is at its limit, but I trust Jinyu, who won, to have his layout at the optimum cycles that it could hit with that layout, because that's just kind of what Jinyu does. So at 541 and 20, Penta Pig's solution ends up with an extra pair of metals on the board after the 6th output, and just pushes them off to infinity instead of trying to reincorporate them into the looping part of his solution. By pushing them off to infinity, I instead mean that they will crash the 2nd time around, but we don't care about the 2nd time around in this category. So Jinyu using this exact same layout as Brookie and as Shadow Cluster with possible changes to the rotation of this glyph. Jinyu is using a 20-to-3 input to output ratio. So there's never a wasted pure projection. There's a pivot here to get this output in. I love this swing back, swing onto the piece here. I will look at what motions are happening that cause that to be required, because I don't think there would be just something for flare in Jinyu's solution. So we need for this, maybe it only happens on the first two outputs. And then again on 4 and 5 because it's periodic in 3. So here, maybe it only happens on 5. I would love to see what is going on in the solution that causes that very visibly swingy bit to happen. There we go. It's trying to pass a Quicksilver from here to here, so it needs to get out of the way, but then the very next cycle it's entirely fine to be here, and it should be because that's what its next step is to do. It's for the metal to upgrade using this projection glyph. At any rate, this solution takes only 515 cycles and is the winner of the area to cycles category for this puzzle, so very good job, Jinyu. First repeat winner of the tournament as well, having won category of sum in week 1. Similar to Penta Pigs, there's some extra pieces left over after the final output is created, so the solution does not loop quite properly. It always expects there to be something on the board during its creation of all subsequent solutions or all subsequent outputs. So that's all the area solutions. So up next are the throughput results, and oh boy was this an exciting category. I will skip over solutions from Above and Kyojin Desu that were both the area solutions submitted as a throughput solution, and we will start with Aberration. So in throughput, it is optimal to always use only the most efficient choices for how to upgrade your metals. So if you use a Quicksilver, it should always be used on the highest value metal that you can. And the other aspect of throughput is, of course, being at input speed. You want to always be grabbing these inputs every second cycle. So Aberration, unfortunately, made basically all the suboptimal decisions here. So of the inputs, Aberration uses primarily the lead and Quicksilver input. Does not use the iron Quicksilver input more than 4 times per output. And the first thing that they do with this lead Quicksilver input is turn it into a tin. They use the tin a la purified gold to cascade through a purification chain and combine it with Quicksilvers that were grabbed from this input, which has been scrapped for its Quicksilvers. The irons are used slightly in terms of speeding up this purification chain, but it still takes 144 cycles to make 2 outputs. It is grabbing this input twice every 6 cycles, so it's at 2/3 input speed on this input, and it's grabbing this one so rarely that it is extremely wasteful in terms of how it's using its inputs, at least in terms of using its time that it could be spending grabbing inputs. When it's not at input speed, it's not necessary to talk about wastefulness of inputs. The more clear shortcoming is that it is not using this input often enough to make up for the time. What I found kind of interesting in a sad way, Aberration's area solve was producing 1 output every 73 cycles. Aberration's throughput solve got a metric score of 72, having produced on average 1 output every 72 cycles, but seems like it took quite a bit more effort to program. So I hope, Aberration, you're able to learn a little bit from what comes up next, but thank you for your submission regardless. Up next on throughput is Kupiowala. So Kupi used this input, but made the same mistake as Aberration did, and always their first step was to project the metal off of this input, and as a result, they are doing a purification chain that is as less efficient due to not having any Quicksilver left to add to the final outputs. They also scrapped their lead, which is going to be a relatively common trend of people who are not doing the full throughput solution, is scrapping the lead because it is the lowest value piece of this entire solution. And as a result of their choices here, this takes 16 cycles per output, so it gets a metric score of 16. Ochre has also created a solution with a metric score of 16, but in his case, it is only using the iron input. This was one of the only solutions submitted to the throughput category to disregard one of the inputs entirely. I would say that of the iron Quicksilver input, the Quicksilver is a valuable half. Another reason that this, despite being at input speed and using a very good pure projection route, is slightly lower for the metric score than it could be is that it throws away some of the quicksilver, which has arbitrarily high value. But to create a solution that seems to resemble the journal puzzle Refined Gold here, and purify the metal that you grab off this input twice, and as soon as it's reached that 2 levels up, you use all this extra quicksilver accumulated from it to finish out this puzzle. It's a clever solution. It's running on a nice loop. It has a nice track loop, but it only has a metric score of 16 due to the choices to throw away the quicksilver and to not use this other input. There would be a way to mirror the solution, use the second copy with the other input, and then pass all this quicksilver into that side instead of throwing it away to effectively double the output speed. You could definitely be able to create another equivalent output every 16 cycles by using this plus what's thrown away by this one. But I believe, talking to Ochre, that time was also a limiting factor this week, so the solution that they did come up with I think is very cool. Next up we have Encaligor. Encaligor's throughput score was 14 and 2/3. And Encaligor used, not this one, Encaligor used no purification glyphs at all. Encaligor made several large waste chains of metal, threw as much metal as could fit into this disposal, and in general only ever projected the metals. I believe they were at input speed, which is, no, there's not input speed on this, but that's okay. I did the calculation at one point when I was making sure that I understood all the scores. In this tape of 3, 6, 9, 10, 40 cycles, no, 44 cycles, because there's one that doesn't happen at all on arm 1, which is setting the... I'm not going to go around hunting for which arm is actually setting the loop to 44 instead of 40, but in the 44 cycle tape, they create 3 outputs, 2 from the iron side, 1 from the lead side, and there's lots of waste being created and pushed to infinity. But I did not disallow waste in this puzzle. The rule was that the solutions in this category must always run forever, and it's easy to prove if the solution just returns to its identical state, but if it's a state that is clearly able to continue adding to waste chains that'll never collide into each other, I consider that fine. So, Encaligor with the only solution submitted so far, and I'm thinking maybe the only solution submitted at all to the throughput category, which did not employ the purification glyph a single bit. It's unique. It's not necessarily the highest score, but it's very unique. So, very cool solution. Next, we have Flappy. Flappy's throughput solution has 2 nearly symmetric cascades. The one at the top is using the lead input, and using a single quicksilver per every 2 leads to speed up the process a little bit. This first glyph always combines a pair of lead, this next one always combines a pair of iron, and then also using half of those outputs, this next glyph combines a pair of silver, which leaves 2 extra quicksilver every time a gold is made, which is perfect. This means that 2 iterations of this cascade at the top will create 1 output. The cascade at the bottom gets to cut it shorter by 1 due to starting two metals up the chain, and also manages to create 1 gold to 2 quicksilver. So the organization of this is really neat. Unfortunately, it's falling victim to the inefficiency where it is using quicksilver on a metal that it then passes into purification. So by using it once, it would have been able to save 1 quicksilver and therefore increase its efficiency. This bottom one creates the output twice as often as the top. The total length is 32 cycles per the solution repeating itself. It might not actually be a 32 cycle tape. I think it's a 96 cycle tape. But regardless, 32 cycles per 3 outputs comes to a throughput score of 10 and 2/3. Up next is Tweedledee. Tweedledee was kind enough to write out their throughput score as part of their solution. So that was interesting to see. Here at the bottom, they have 64:7 written in equilibrium glyphs. There was no penalty in this puzzle for using extra area. The only tiebreaker to have on throughput was cost. So you could use as much area as you wanted. You could use as many cycles as you wanted, even as long as your throughput was a score that I could calculate. So it runs at input speed on this input. It runs at input speed on this input. Where does the inefficiency come in that causes it to score lower than what is I considered a simple score of 8 or the try-hard score of 160 to 21? And so what you can see here is that 2 silvers are being placed on an output purification glyph right here, but these silvers both had a quicksilver spent on them, so it would have been more efficient to take 2 of these coppers, purify them to silver, and then project to gold, leaving you with 1 extra quicksilver. That means you'd have to reconfigure how your design works so that you always end up with a balance of quicksilvers instead of just like, if you're generating extra stuff, that doesn't necessarily mean you're able to generate more outputs. It'll be shown later that, yeah, you could throw away all of the lead in the solution and get a throughput score of 8, but you can't create this output from lead alone. You don't have any quicksilver to use. So possibly this inefficiency was noted, and just you could see that, oh, well, I'm going to be saving a quicksilver, but what does that give me? I don't know if there were other similarly inefficient choices. Yes, here's another. There's an iron here, which is thrown onto a projection glyph before passing into purification. So there's 1 more wasted quicksilver from here. It might not be the only pair, but the fact that there are quicksilvers being wasted where quicksilver has arbitrarily high value does hurt the throughput of the solution a little bit. By being at input speed, though, it is able to at least keep itself close to what I would consider the good score of 8. So now we get to look at all the scores of 8. Now, my idea of an 8 is to create the solution to reactive gold, which is another pure projection puzzle in the journal. And using, here, I can actually open reactive gold to show what I mean here. I cleared my solution files to back up, so I can't reasonably do that. But reactive gold is a way to create to use 4 of this input to create this output. It takes 4 of this, it purifies all the iron, or all the lead up to iron, and then it uses 3 quicksilvers on projection and 1 on bonding to turn into a gold bonded to a quicksilver. If this was instead an iron input with a quicksilver bonded instead of a lead with a quicksilver bonded, you could choose to do 3 quicksilvers for bonding and 1 for projection, and make a gold with 3 quicksilvers bonded to it. So a gold with 3 quicksilvers bonded in a specific pattern, and a gold with 1 quicksilver bonded can join to make this ring. So if you solve reactive gold twice, and you join the pieces appropriately, you can get a throughput score of 8. And so now we can see that there are lots of people who made that exact decision. Monster Racer being the first. The first because of the intensely high cost of a track loop with several arms on it. But they're doing the exact thing that I mentioned for reactive gold, where you purify it by 2 levels, and then you project once, and then bond 3 times. On the lead side, the exact same machinery happens, but instead of project once, bond 3 times, you project 3 times, bond once. And you end up with gold with 3 quicksilvers bonded, gold with 1 quicksilver bonded, and voila, the output. Up next, we have a solution from Chickens in the Attic. He sent me 2 throughput candidate solutions, and I'll show you why that is. So he also chooses to do the refined gold times 2 approach, where there's iron purified from the lead and silver purified from the iron, 3 bonds on one, 1 bond on the other. But these track loops here, in this iteration of the solution, there's 12 arms, 8 arms, 8 arms, and 8 arms. Which means that the period of this solution is 48, because you can handle the fact that each of them needs to return to their starting position, and they're on every 2 for their behavior, with only an LCM of 48, for least common multiple. There were quite a few discussions he gave me about how the LCM of his solution would be so much larger if he reduced each of these track loops to their smallest number of arms. So while some people had long track loops because they were trying to hit a perfect throughput with a lot of products per instruction tape, Chickens in the Attic's problem was from the fact that to make the solution slightly cheaper at the same throughput, reducing the number of arms on these loops, he would need to build this solution instead. This has 10 on this, 7 on this, 7, and 8. And because 10 has a factor of 5, And then there's also a factor of 7. There's a 2 and a 3 throughout the solution. So 2 times 3 times 5 times 7 times 8, because 8 is the actual period of outputs. Leaves an enormous LCM for this. I think it was a 1680 LCM, which means that there would have to be 1,680 instructions for every single arm. And that was too much. Fortunately, the difference between this solution and the one that we just looked at that had a period of 8 and an instruction period of 48 was not significant and did not change his standings. That way I didn't have to make the hard call of, is it better to use the one that is cost optimized but has an insane LCM that nobody actually bothered to pad out, or is it better to use the one that is actually simple and straightforward to run? Regardless, at Throughput 8, this one at 1,470 gold beats the previous solutions. But again, it's not coded to the end, so we have to use instead the 1551, but that's no different in terms of placement. Up next, there's a solution from MatterMonkey. MatterMonkey, similarly to Monster Racer, uses this large series of arms to delay the Quicksilver and adds a ton of cost, especially because this is a piston loop. There will be much more elegant ways in the near future that use 6 arms or bonders to stall the Quicksilver without taking as much cost. This is also stalling of the Quicksilver, but it uses several arms. But it seems to be slightly more cost effective than this one at the bottom because they get to be in bonded pairs, so you only have half as many arms required. So he's on the right track to getting that the true cost effective way of getting this Quicksilver storage. But again, you can see that this is the refined gold process doubled. So here's the silver coming out from the purified iron, and then here's the iron coming out from the purified silver. And they both land on the same purification glyph. So there's at least the nice feature that purification is happening in only one place. This is a good solution in that it uses a single purification glyph, which helps it stay very centralized. But again, because of the small inefficiency where you're purifying an iron, but you're also projecting an iron, but you're also purifying 2 coppers, this is going to lose a little bit of efficiency versus what's optimal. And I believe MatterMonkey sent me a message during this week saying, I know that the maximum throughput is slightly better than this. It's between 7.5 and 8, and I'm not willing to go that far. So for a solution that took only as much effort as they were willing to go to, this is a very good solution. At 1190 gold, this is better than all the other 8s we've seen so far, but 8 can get quite a bit cheaper. Next, we get to look at Axel, who also made a solution with a throughput 8. Axel's was called What Extra Latency? And I believe that Axel just optimized for cycles here, because there is no extra latency. This is bonded as early as can be done. This final gold is thrust immediately into a multi-bonder so that it can output on cycle 20, and it outputs again every 8 cycles from 20 onward. So this gets a score of 60 cycles, which was the fastest solution submitted this week, despite not being exactly optimal throughput. So the reason that this reactive gold clone, where you solve by upgrading each metal off of the input twice, regardless of whether it's a lead or an iron, and then projecting the appropriate amount of times to get this output. The reason that this isn't optimal throughput, and this is an interesting thing to think through, and I'll spend a little bit of time on this solution specifically looking at it. Here there's an iron which you put onto a projection glyph. So you're spending a Quicksilver to turn an iron into a copper. Here, there is a copper which is being placed onto a purification glyph to create a silver. It's not the exact same copper which was just created out of this process, but every copper in the solution has the same value. So a copper created in this way is equivalent to a copper created in this way, even though their routes of creation were different. And so this copper, which ate a Quicksilver in its creation, is being put onto purification. If you imagine that being done twice, you have wasted 1 Quicksilver. This is the exact same issue as was shown much more explicitly in the very beginning of this video. But it happens much more subtly here because you have to take into account the fact that coppers in 2 different locations in the solution still have the same value. So with a throughput of 8, Cost of 1190. This beat the previous one on the cost tiebreak, but is still not at optimum efficiency. It's at minimum cycles, though, for its route, which is extremely cool. And this track loop full of arms pushing the Quicksilvers along is funny to look at. Next, we have Starfish. So Starfish's solution is labeled suboptimal because I watched. He was working on this all the way up until the deadline and sent in his every 8 solution, even though he knew that he could do better. And this isn't every 8 that throws stuff away. It takes 48 cycles to create 1, 2, 3, 4, 5, 6 outputs. So per 1, 2, 3, 4, 5, 6. It's doing every 8 through 48 cycles to 6 outputs. But in those 48 cycles, there's also 2 Quicksilvers and a copper, I believe, being thrown away. So 2 Quicksilvers and a copper doesn't have the same balance problem that was mentioned if you only have lead waste or you only have Quicksilver waste, where that can't actually build an output. You can build an output out of what Starfish is throwing away, but it isn't a very clean ratio to get from those excess into this output. And so for that reason, I don't think it was something he was able to figure out in time. Also, he probably didn't leave himself that much time. That's okay. This is only a 10-day puzzle. People aren't able to spend months and months figuring out these solutions. They are throwing it together based on a puzzle being announced on a Friday and due a week from then on Monday. This solution also has the property of there's a small amount of material which is put off to the side once. This arm 1 that drops it won't ever grab it again. It won't ever grab anything again. It's using conditional logic to only grab things that were rejected by this input, and that's only the very first time something is put here the arm 1 is going to act on. This also doesn't disqualify solution from being maximum throughput. It does give it the slightly distasteful property that there is not going to be every atom that is on the board output, but that's also true of things that use the disposal glyph. Finite one-time storage is basically equivalent to a disposal glyph. So it's interesting to think about what would have happened if Starfish was able to create what he wanted out of the solution, but he instead sent me this thing called Lag City, which my computer doesn't enjoy running, but it's not the absolute worst. Yeah, this laggy solution from Starfish was submitted after time and did not successfully loop. It creates 4 extra outputs per the 960 cycle instruction tape. So it is a little bit worse than optimum throughput, but it is a little bit better than 8. So after Starfish was Spar. Spar had another every 8 solution. Frequency 8, cost 1000. This was doing the refined gold twice approach, where each metal is purified twice. Here we have iron that is getting its 3 projections. And here we have getting its 3 bonds. I like the use here of a 6 arm that is rotating in a conveyor belt fashion to store Quicksilver longer than it needs. Like, there's excess Quicksilver if you use the purification first, because purification takes time, and you end up with a lot of Quicksilver that you have to store. And we saw some of the previous solutions do these massive track loops that are very expensive. If you want to work not in a line, but in a circle, you can use a single 6 arm. It limits you to only 6 delays, but it does let you do it so much cheaper. This costs 30 gold to place one of these on the board versus the track loops that cost over 100 gold, and depending on how many arms, can cost 200 or more. So these delaying 6 arms were able to make this quite a bit cheaper than some of the every 8 solutions that we've seen before, specifically Axles and Monster Racers. Starfishes is kind of a different category. Up next we have Hutobi. Hutobi submitted an every 8 as well. The title of the solution was I Should Probably Use the Lead. This is the first solution we see that throws away all of the lead. Now, it's possible to get an every 8 using only the Quicksilver off of the lead input. And the route to that is to make the gold with... these 4 inputs of this turn into 2 gold exactly, no extra Quicksilver. But then 4 inputs of this turn into 4 Quicksilver, which is exactly what's needed to create the output. So it's a different path than the doubled reactive gold, but it turns out to be a very efficient path in terms of getting to every 8 cheaply. And at 520 gold, this was the cheapest submission at every 8. That doesn't mean that it is the cheapest solution overall to be every 8. There was a solution that was posted into my DMs by Brooke that hit 430 for every 8 before Brooke realized you could do better. And then after the fact, I went and I optimized to get every 8 using the same approach as Hutobi and Brooke that throws away all the lead. It can be done in 370 gold. It's using the same 6-arm conveyor, but this conveyor is actually advancing the progress of the output, where it first bonds the 2 quicksilvers, then it allows the bond to a metal. It gets upgraded twice. Another arm will move it into position so that every second one of these that is being conveyed by this arm will end up also finishing off an output. And this particular construction is the only way I could find to get 4 arms to deliver quicksilver on 2 adjacent cycles to this point. But yeah, 370 gold is, as far as I'm aware, the best that anyone has come up with for every 8. So from here on, everything that we see is going to be optimal throughput. No one is actually... So Starfish had a approach that was nearly a value between 8 and optimal, but the only things that were actually submitted and scored were either 8 or worse, or they were optimal. And the first optimal throughput solution that we look at is going to be RP0's, called Magnanimity. So, we see first this giant piston track loop. And we also see that he is creating a line of bonded metals. Some of them are silvers, and some of them are coppers. And he has this piston track loop add enough quicksilver to always create a line of bonded gold from this, regardless of whether it's silvers or coppers that come in. The calculation that was done to determine when to add a silver versus when to add a copper is a little bit non-trivial. I would like to first look at the other side of the puzzle. This one is taking 8 inputs. 8 inputs is always being used to create 1 copper here, and then that copper is projecting always on the 2 quicksilver that are being stolen from this chain that is being built on the bonder. After the 2 are stolen, everything else is used to create these bond candidates. These quicksilver will only be part of bonding in the output. So, how do you get 160 cycles to 21 outputs from this? Well, everything is moving at input speed. So what we need instead is to consider how many inputs to become 21 outputs. That would be 80 inputs to become 21 outputs. And working towards creating a solution, the way that you would approach this uses some linear algebra. There's a balance equation that you can solve that I'll flash up on the screen at some point. I probably already have flashed it up on the screen, given that I promised to do that earlier in the video. And it tells you that of every 50 copper that you handle in your solution, you want 16 of them to purify into silver. You want the other 34 to stay as copper. That'll allow you to use as much quicksilver as you can to reach gold and have exactly 2 quicksilver left over for every gold you create, meaning you can create the perfect output ratio with no waste. So because the right half of the solution, out of 80 inputs, will create 10 copper, and all of them are going through this projection pipeline, what's left is a 24 to 16 ratio. So you want 24 copper to go down into this line as copper, and you want 16 to be turned into 8 silver. So that means the ratio of silver to copper in this chain should be 1 silver and 3 copper. And then, knowing that that's the intention, you can look here and see 1 silver and 3 copper being added in that order every single time. So if it's proven by math that that will always let you have the right output, the rest is just assembling it. And the assembly process, convoluted-ish, I don't want to fully follow it. There's 160 cycles of instruction tape here, so there's plenty of freedom for the arms to always do what they need to do to not crash. In fact, I put 320 cycles of instruction tape here because I wanted to record a GIF of all of these solutions, and when there's a long instruction tape and stuff hasn't started happening in the bottom part yet when the first output is dropped, that causes the GIF to not loop properly. So there's a trick to double your instructions, make a GIF that way, and then trim out using a GIF editing tool the second half when everything is already filled in this pipeline. But RP0's actual submission only had the first 160 instructions of this, and in that case, it had enough instructions typed out to make sure that these arms can create all 21 outputs during that 160 cycle loop. The main solution tactic which was used to make this ratio possible was counting for every 50 coppers you create. 34 of them are purified. 34 of them are projected, and then 16 of them are purified into 8 silvers. At 2,535 gold, this was the most expensive machine submitted this week, but it is the first max throughput solution we have seen. So it also very cleverly demonstrates the ratio that we were looking at, where you can turn this weird 34 to 16 number in using 10 from over here that are guaranteed to come out of 80 inputs to become a 1 silver 3 copper that makes a lot more sense to the viewer. All right, moving on from RP0. Next we have SGS. SGS had also a perfect throughput solution, and it is a little bit sprawling. The copper is traveling all over the place. Due to not being quite as organized as RP0's, I haven't yet been able to fully understand where the 34 and 16 decision comes in. But I can see that there is a silver here, which is clearly created from 2 coppers, but ARM40 has yet to handle it. And I'm wondering how much instruction tape passes before ARM40 does handle it. Oh, there it is. And so that causes there to be an extra gold in the assembly pipeline. Now, the quicksilver in SGS's solution mostly comes from the lead. The lead is actually purified all the way to silver, which means that 16 lead come out to 1 silver and reduce from the 16 side of the 3416 5 times. So you end up with 3411. That causes it to be a little uglier. I imagine that... No, it's not 3411. You take out 10 copper by getting pairs of them here. So it is still 34 to 6. So there need to be 6 purifications happening on this side of the puzzle. And that is what's happening. ARM26 will at some points drop into here. There are 3 silvers created on this half of the puzzle to finish out the 5 that are created over here. And that causes it to be optimal throughput. The output that is created at the bottom of the screen follows this nice handoff path. There are 160 outputs, or there are 160 cycles in which 21 outputs are made. 20 of them come from up here on an every 8 loop, and 1 of them comes around the bottom. That tactic is going to be common in a lot of the solutions later, which will use what I usually call an odd one out pipeline. It's not a trivial odd one out pipeline because of the fact that there's so much extra purification math to make sure that you get the right threshold between silver and copper, but an odd one out pipeline where the output is mostly serviced by something that's operating as fast as it can reasonably do, and the remainder that still is left over, 160 can create 20 here, there's 1 left over, and that is delivered up the bottom every 160 cycles, every 20 outputs created here. We'll stick around a little bit longer to watch it come out from the bottom. There we go. So that'll happen once every 160 cycles to turn this from 160 over 20, which is 8 like a lot of the other solutions, to 160 over 21, which is optimum throughput. At 1890, this was the second most expensive submission this week. Now we'll look at Sivir. Sivir seems to have opinions on this puzzle, called Siv Hates Biggie Now. But I watched Sivir do a lot of the math in terms of realizing that 34 to 16 ratio in my DMs, so I got to see a lot of his thought process, and he was able to solve this puzzle mathematically very early in the week, and creating the actual solution here took a fair bit of time. It was not until close to the final day. So let's look for where copper is purified in this solution. It's happening when ARM35 delivers. I don't have off the top of my head how frequently that happens and whether that corresponds to all of the necessary copper, but it looks like it's happening once every 20 cycles. So this is doing 8 purifications over the course of the entire puzzle. So it's using 16 copper exactly. So this is the only place in the entire solution then in which copper is going to be purified into silver, because it's doing it once every 20 cycles, which is how often that should happen in an optimal solution. Which means everything that's coming out of the lead pipeline, as soon as you have copper, it's time to project it. So it fills these two projectors, uses that to make a gold, uses that to make an output, and creates one output every 16 cycles up top, another one output every 16 cycles somewhere else. Looking at the output, it's not clear how the pipelines actually converge. There's not a 116 plus a 116 plus a 1 over 160. It's slightly more tricky than that, but it's very well organized in that there's exactly one spot in the level that is causing the 34 to 16 ratio, and it's happening on as regular of a cadence as is possible for this solution. So it's well organized in that sense. It also demonstrates this 3-arm track loop here to push things out into a bonder. This isn't the most cost-efficient way to do this. You could use 6 arms on 2 tracks. Not a 6 single arms, but a 6-pronged arm. And that would come out to identical to this, actually. So scratch that. This is equally efficient to what is optimal. But it's creating this bonded chain, which solves some of the problems that other solutions we're seeing of quicksilver storage. And you don't have to use a rotation to solve it. You can still make a bonded chain as long as you use the bonder and then you grab it off of a debonder at the other side. All right, so Sevier with 1,520 gold is the next most expensive of the max throughput solutions. After Sevier comes Brother Mojo, and I really like Brother Mojo's solution here. It solves the quicksilver problem using a swinging chain. And it takes 2 positions every other cycle. And because the copper pipeline can produce a gold every 4 cycles, it's exactly able to just bond that gold into place and then break off a trio over here on the right. So if this was all the solution was doing, it would be every 8. But you can see that it is slowly acquiring excess. Over the course of 80 cycles, it generates an extra 1/2 product using a bit of fancy copper swapping. We'll look at that in a moment. I want to focus first on how it reintegrates that into the solution. So instead of bonding 1 gold, it bonds the gold plus this new triad, and then it breaks off an entire output over here instead of a half output. These arms have a slightly different program, but nothing has to change in the handling of this stick from its ends. It's a very, very slick reintegration of half outputs that seems to take no extra burden on these arms. They don't have to add new costs for it. So the extra switch to get from every 8 to 21 every 160 didn't add much cost, and that was really clever. So now let's look at how the copper ratio is being handled. So it's not necessarily clear looking at this what's going on because it is all so compact. But the purification glyph right here under the 3 tiles that I'm trying to highlight serves as 2 functions. It both turns a pair of tin into an iron and then a pair of iron into a copper every 8 cycles. The pair of tin into an iron is going to help handle every single metal that's coming out of the lead input. And then the pair of iron into a copper is to handle the single extra iron that comes out of this input every 8 cycles. So it's the other 3 that come out of this input that we're curious about here. Because there's going to be a copper being made, but then it's at a different cadence than the copper being made out of here. There's 1 being made every 8 here, and there's 3 being made every 16 over here. So of those, every 20 cycles it looks, there's a silver being made. And that silver, by virtue of coming in here, replaces one of these quicksilver. And so by making a silver, you kind of earn back quicksilver from this feed. And some of the arms end up delaying that quicksilver and then putting it back in later because of some other workings of the machine. But sometimes it's a true earned quicksilver. And there's also points where it has to be an earned metal. And so I'm trying to find out where the metal is stolen out. A metal that is deposited not on this bonder, but makes it out of the solution somewhere else. Gold, 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 new gold. Yeah. So this gold was stolen out of that other pipeline but there was enough excess being created here to keep filling this gold every 4 cycles. So that's when the gold is liberated. And then every time that they purify silver, they're able to liberate 1 extra quicksilver. So let's see, based on the ratio, you want to liberate 4 silvers per 80 cycles because they're doing a half outputs creation. So it must take 2 silvers to earn a gold and 1 silver to earn a quicksilver. And that makes sense as like an exchange, but it's also done so elegantly and very compact. It's hard for me to say exactly what's going on here, but I do love how slick this output mechanism is. So very good job, Brother Mojo. 1175 gold to make this output. Next we have Peen Locket. So despite what Peen Locket had claimed earlier, like not quite understanding purification, they seemed to figure it out in terms of making their throughput solutions. It's probably a crash course for them because they had mentioned that they still hadn't solved reactive gold optimally. They had only done it using classic pretty solutions that they like to make. So ARM 23 here is doing, this ARM wears many hats in effect. Twice during the creation of this solution, ARM 23 is responsible for walking a gold that's excess from the rest of the solution down to the bottom. And when it gets passed down through the bottom through ARM 25 to 27 to 26 to 30 to 29, that extra gold is used to finish off a couple of products that are created lacking in their final gold. It's also used to create this extra output over the course of the solution. So ARM 31 here starts to acquire all those sparse quicksilvers, and the extra golds are helped finish off that too. So let's see how those quicksilvers are effectively earned from this operation. The standard process here is creating an output or an output that's missing a small piece every 8 cycles. So when this is a copper that is taken directly from copper to this projection glyph, the outputs that are made are true. If it decides to miss one of the copper, it seems to always miss the second one. Missing the second copper allows it to still be bonded in 5 atoms. It's just going to require the gold to be supplied from a secondary source. 4, 1, 2, 3, 4, 5, 6, 7. I'm trying to get a sense of how often this copper is going to be moved onto this purification glyph. It looks like in the lead pipeline, the projection goes all the way, well, looks like I'm looking at the wrong part of the solution at the wrong time twice. Because sometimes the silver is being created over here, and sometimes the silver is being created over here. If the silver is being created over here, 22 is going to do a diverted route. An output's going to come out without one of the golds, and a silver is formed here, which is one of the 8 that needs to be formed every 50 inputs, or every 80 inputs, every 50 copper. When it's formed down here, that might be only once during the whole run of the solution, and that's for the purpose of finishing off this sneaky assembled product where 31 stole some quicksilvers. There are a couple of extra tricks that are in balance to make sure that this keeps up the optimum throughput. To be fair, when I calculated optimum throughput, I just looked at how many instructions executed and how many outputs were being created in that, so these specific tricks that were being employed by the solver to make it all work out sometimes is just best explained by the solver. I can do what I can to understand this a little better. It's definitely earning quicksilvers from this lead input. ARM 21 is going to start passing things off to 31. How often does it snag a quicksilver? It's happening every 8th input for a small section of the machine's operation. And that seems to align with exactly when it's doing this. So once every 8th input, it steals a quicksilver and it starts to move things out to the silver at the bottom instead. It all balances out. I don't know how. Good job, Peen Locket. I'm going to move on. Shadow Cluster made a 1115 gold optimum throughput solution. This uses what I talked about earlier of 2 6 arms on 2 tracks. This is what I would consider the most clean way of creating a bonded chain, but what Civ had done with the three-arm loop also works. I think the disadvantage of the three-arm loop is that it forces your period of your instruction tape to be a multiple of 3, where 160 is not. So it causes 160 instruction tapes to become 480 instruction tapes. And that's just a slight... it's an inconvenience to have to triple your instructions just to make sure that your arms on your track loop work out. That's known to a lot of solvers as the LCM issue, the least common multiple of all things that have to repeat on your cycle loop. Ends up setting how many instructions your solution has as a whole. So we have 2 feeds that are a line of Quicksilver, and then the metals are being specifically processed. Over here there is an optional purification glyph for copper. It looks like it's being used on a regular cadence. Let's go look at ARM 16 to see how regularly. There's 6 cycles on 3, 6, 20 cycles total, and it's doing that regularly throughout the solution. So yeah, this one is doing a purification every 20 cycles. So in the same way as Sivri's solution, it's doing it as regularly as is possible. The other one comes from ARM 17, which is serving dual purposes. So in the interest of minimizing cost, being able to do the 2 different types of tasks with a single arm is good. Here ARM 17 is generally delivering these down to be part of the purification or the projection chain, but whenever it is a copper that is scheduled for purification, it can deliver that one simply. That also means, though, that because this one's handling the purification every 20 cycles, that every copper that comes out of this lead half is immediately just delivered into a gold, and it purifies all the times it needs to. Knowing that everything is in balance, the process of actually assembling all the rings, as we had said in RP0's solution, there's a lot of cycles to work with. These arms might have a handful of tasks. They're balanced well enough. In terms of cost optimization, how those final outputs are assembled in a not overly expensive fashion is important, but given in terms of just understanding the solutions, knowing that all the ratios are in balance is usually enough. There's not really a surprise to be left in the programming of these arms. So we can assume that the solution is pretty easy to understand, and it is. So good job, Shadow Cluster, on a well-organized, good cadence for the copper non-triviality and getting these outputs created very elegantly. I do particularly like these 6 wheels of delivering these metals onto this glyph. This is, funny enough, in a cycles, or effectively cycles with Throughput solution, there's still an indirect glyph right here, because you can reach it by always taking this triply bonded thing and putting the metal part of it on there. I thought that was cute. Next up is Larsdahl. Larsdahl with another optimum solution. So using a track with 4 arms to create this bonded chain. 4 arms is probably a choice made because of the fact that 3 causes throughput issues, or causes LCM issues. I'm sure that the way that Civ used to create the chain with only 3 arms on a track is applicable here too. What was nice about Larsdahl's solution is that it is 80 cycles, or 80 cycles of instruction tape. So here, ARM24 is given effectively conditional logic, where when it is able to identify an excess Quicksilver in the chain, which is handled by machinery that we'll understand quickly, it first generates half of an output, drops it here, and then ARM25 does an effective check to see if it can output that. If there's nothing to grab because the output's only the bottom half, then ARM25 is meaningless. If ARM24 is able to turn around the piece here because ARM25 didn't grab it away, then it makes the top half. So it's using conditional logic to effectively have the period of its solution, which is a good thing for instructions optimization as well, but in this case it's mostly for programming optimization to prevent Larsdahl from needing to write out 160 instructions. So we can see that he's using the every 8 assembly line over here, so this is an odd one out effectively, the same as the other ones that we've seen. And the every 8 pipeline looks very consistent. In fact, it's actually a pair of every 4 pipelines with conditional logic yet again. If the output drops, ARM32 will not have anything to grab and deliver to this half. If the output doesn't drop, then we can help finish the other half of the output with it. So Larsdahl saving programmer effort by doing conditional logic in Opus Magnum is very clever. And how these half outputs are assembled resembles Brother Mojo's solution quite a bit. So making the snaking pieces of quicksilver and iron, and then making sure to always put a gold here every fourth cycle. And that gold is not always created in the same path. Clearly there has to be some non-trivial machinery here that makes the copper always come out to silver, but with purification used on 16 of them and projection used on 34 of them. So the 34 that project have to project twice, and when it's a silver, it only has to project once. So when that happens is when this silver is earned. The gold is earned when arm 20 grabs this silver and is able to generate more golds than are needed to be over here in a 4-cycle window. That's like the accumulation of excess in the solution allows this silver and the silver that would ordinarily sit on this projection to allow something, it looks like it's arm 23 that actually does the deed, to put something up in this multi-bonder here that is the excess gold. Yeah, there we go, arm 23 finds an excess gold that isn't needing to be delivered out to here. And that's how this solution earns itself a gold. Earning itself a quicksilver is rather simple. Every time you choose to purify out to a silver instead of project, you earn a quicksilver. So yeah, in this way, the solution achieves that same 160 to 21 ratio. I really like this simplicity of the quicksilver chain where you add a gold to it. The conditional logic here, both for the regular output loop and for the output loop that's the odd one out, to cut the cycle solution or to cut the instruction tape in half. This is a really elegant solution. And at 1095, it's the first that's under 1100 gold at this throughput. Mr. Puzzle had another slightly improved cost from the previous at 1050. And this one uses the 6 arms for quicksilver storage, but it's the only one that I've seen which chooses to reset them anyway. There's nothing gained by that extra instruction other than maybe a rotary telephone aesthetic, which I don't dislike. I just find it kind of funny because every other solution that uses these 6 arms for quicksilver storage, move, rotate, drop, dead cycle. This one chooses move, rotate, drop, rotate back. So now let's see what the actual process is for creating these outputs. So I can already see that there are 3 different positions where the output is being created. And this makes me think that it resembles my approach to this problem. So is this going to be where I get to describe the 3 pipelines approach? Let's look really quickly first. So yes, this is identical to my approach in terms of the pipeline balance. So on the lead side, you get rid of every other quicksilver from the lead side and deliver it to this 3rd pipeline. Meanwhile, you get rid of some fraction of the coppers from the iron side and deliver it to the 3rd pipeline. In that way, the iron pipeline is able to produce an output every 16 cycles. The lead is able to produce an output every 32 cycles, leaving 6 outputs which need to be produced over the course of 160 cycles by this pipeline that is being fed some irregular stream of copper and quicksilver. And that's non-trivial, but this 3rd pipeline is not fed fast enough to be impossible to solve. And it's able to be solved rather cheaply. So that's why I chose it for my solution. It turns out it's not actually the best approach. Someone beat me by quite a bit. But regardless, I like this 3 pipelines approach. The decision to be made in the 3 pipelines approach, though, is where you actually purify the copper into the silver. So here it's being purified in golds that end up being part of the 1 every 16 pipeline. If this is the 1 every 16 pipeline, I'm not actually sure anymore. It looks like it is. I'm not sure whether the one that's going around up the left or the one that's in the middle of the bottom is the one that's producing the high ratio output. It looks like it's the one in the middle of the bottom that's producing the high ratio. ARM 19 looks like it's busy on every 16th cycle. Yeah, ARM 19 has a 16 cycle loop. So the middle bottom pipeline is the one that is producing excess of the copper. And the one around the left is the one that's joining excess quicksilver and excess copper. Actually, this one is producing excess quicksilver because of the fact that it's taking as input the excess quicksilver from the lead side. So the pipelines are handing off in a slightly different manner than in my solution. But it is still the same addition problem of every 160 cycles, there are 10 coming from here, 5 coming from here, 6 coming from here. And that makes 21. So I think it's actually very interesting that the quicksilver excess from the lead side that is being delivered here is enabling a quicksilver excess on this side that there wouldn't be without it. It's an equivalent excess being handed off from here to here and from here to here. But it helps keep the solution organized, and there doesn't have to be like this weird, complex, four-connected graph of pieces that try to communicate with each other. You can just hand off from one to the next and cause the handoff to be enabled for the next to the next. And of course, whenever there are 3 pipelines, one of the biggest questions is how they all converge. But the output seems to be positioned in a very convenient place for everything to be joined and dropped out by these 3 single arms that don't even need any track. So for that, Mr. Puzzle has extra kudos for their layout. They don't have to do any long walks like we've seen in some of the previous solutions where an output is being created somewhere off very, very far from the output glyph, and then this whole chain of arms walks it around and puts it into the output glyph. Here, every pipeline terminates at the output glyph modulo a single arm. So that's really elegant. So good job on this solution, Mr. Puzzle. Next, we will look at Feindir. Throughput 11. I'm wondering whether that means it's the 11th iteration of Feindir's solution. So Feindir uses a 6-arm to deliver increasingly growing quicksilver pairs that become half outputs when the gold is dropped here. So similar to Brother Mojo's and Lars Dahl's solution, the contract being made by this section is that there will be a gold placed in a specific location on every 4th cycle, not necessarily by the same mechanism. So ARM 12 is delivering the golds on the regular case. ARM 24 is delivering the golds on the exceptional case, but the output is agnostic to whether one case or the other was being used. And in that way, ARM 18 is able to deliver an output every 8 cycles. So this one's using an odd one out pipeline approach. There has to be one extra output delivered every 160 cycles in order for the solution to reach maximum throughput. So we can see that the extra leads that are being created on this right side are going as far as copper. And then those coppers are sometimes becoming silvers. And every time that you have a copper that would have been delivered by ARM 10 into this projection glyph for the standard approach is instead delivered to this for the exceptional approach, that earns the rest of the solution a quicksilver. Earning the rest of the solution a metal is it equally? Yeah, the part that most interests me about the odd one out pipelines, because I didn't solve this type of solution with my own approach, is so earning a quicksilver is rather trivial. If you can create an excess copper, you can swap it into your solution to get yourself a quicksilver. Earning an excess metal, I guess that just, okay, yeah, the excess metal is created from 2 coppers that don't get swapped in. That makes sense. So you have a copper here, and sometimes that means you swap it in and earn a quicksilver. Sometimes it means you don't swap out anything from this main pipeline. You just take the 2 coppers you got, turn it into a silver, and here 22 to 28 to 26. We'll watch it come up. I believe it's coming up on the next. No, there's one more exceptional quicksilver, and here we go. This silver is just passed through the solution, kind of in an unlikely manner, to get to this projection glyph, turn into a gold, and turn into the odd one out pipeline output. So yeah, these extra coppers that you earn get swapped in either to earn a quicksilver or to earn a silver. And when you earn so you have to earn yourself 6 quicksilvers if you're generating silver for the output. You have to earn yourself 2 silvers, which each cost you 2 copper. So yeah, every 10th copper, you're able to produce an output. So it takes you 10 coppers, aka 80 inputs, to produce this extra output. So that's exactly the 160 to 21 ratio we're looking for. This is actually a very illuminating solution to figure out the odd one out pipeline approach. So very good job, Feindir. And at 935 gold, this is it the first sub 1,000? Yes, it's the first sub 1,000 we've seen to hit this throughput. Up next, we have Panic. Panic cost optimized full throughput at 905. A few people refer to this, because its ties are broken by cost, they refer to this solution style as COFD or COFT. That was made popular by Darvish on subreddit, who decided that cycles as a solution tactic was a little bit arbitrary because you were incentivized to spend all this extra money to squeeze down the latency when these things that are supposed to run forever are going to not care whether the first several thousand outputs are advanced by 2 cycles to anyone who's in universe, and argue that the cost optimized full throughput was the more in universe reasonable way of deciding what the best fast solution was than a cycle solution. Unfortunately, Darvish has since not played this game quite a while, so don't get to have solutions from them in this tournament. But the cost optimized full throughput metric has proven to bring a lot of really cool solutions out here. So now let's look at Panics. Panics is definitely an odd one out pipeline because you can see that there are, every 8 cycles, there's something going to this output. The contract being made is that a gold is going to be dropped on this bonder every 4th cycle by one of 2 agents. Arm 7 can handle the exceptional case, Arm 1 handles the ordinary case. If Arm 1 isn't handling that case, it looks like that's when Arm 1 doesn't handle something, there's an excess that is generated down here, either a copper or a gold. And then when and where is that extra output assembled? Because there's not much machinery left to look at. This trimmed down to 905 gold. It's very interesting to me. So I guess Arm 6 here that carries a double Quicksilver, those are earned Quicksilvers. Those are earned excess when there's the exceptional case happening over here. And so in that case, there's a gold being delivered to this on 2 consecutive cycles. So it's handling the every 4 contract that it's supposed to be holding, but Arm 7 just dropped it. There's an extra gold being created here. And so that is held off to the side at some point by this. Yeah, the excess at one point is being held off to the side. I guess since Arm 5 has a low duty cycle, it's only acting 4 out of every 8 cycles. It's entirely reasonable in its solution path for it to just drop something off to the side, and then when it has excess, drop it off again. What I find also interesting about Panic's solution is that there's an excess. A Quicksilver is thrown right here at some point, and I'm not sure whether it's used. Yeah, Arm 8 looks like it acts once. No, Arm 8 actually has a purpose. I guess I'm curious. Oh, that makes total sense. Okay, so there is an excess. By starting the lead as early as he does, Panic causes this Quicksilver right here to not be consumed before it would cause a crash. And instead of letting a metal work its way to this projection, he has conditional logic that one time in this solution will take this Quicksilver, which wasn't used by a metal before it would cause a crash, and throw it off to the side. It's conditional logic because all the other times that same code path runs, right here, the metal already stole that Quicksilver, so 8 has nothing to grab. So there's no crash caused by it. So this Quicksilver is the first excess, and because this Quicksilver is here, there's a metal that's missing somewhere. There's another excess that is similar as we saw in Starfish's solution, a product which will never get finished. But in the infinite limit, this is still producing 21 every 160 cycles, so it is optimum throughput. These just like one-time initialization things that require conditional logic, I think are pretty neat. So yeah, the contract is being exceeded here. The one extra half gets dropped off to the side. Arm 5 with its low duty cycle is able to come in and grab it again to finish off an additional output other than its 1 every 8 that it is otherwise creating. Here we go. And yeah, a very elegant solution to this max throughput problem. 905 gold. Good job, Panic. Up next, we have Penta Pig. Penta Pig took a unique approach. I don't think anyone besides Penta Pig took this specific approach. Down here at the bottom is a machine that is using 2 of this input and excess Quicksilvers coming out of this pipeline to produce an output every 8 cycles. But instead of having an odd one out, it just pauses that machine for 2 cycles at 3 points. Or no, pauses the machine for 4 cycles at 3 points throughout the execution. So that, in effect, causes what should have been 20 outputs to become 17 outputs. And then the other pipeline has to generate 4 outputs during the entire solution to bring it up to 21. So during those paused cycles here, you can see arms 4 and 5, which are ordinarily delivering downwards to feed this bottom pipeline, just switch and instead deliver upwards. 2 inputs are moved upwards. And it becomes sort of a cost-optimized problem for how arm 25, serving as a very slow-fed input source, can assemble all those other 4 outputs to complete this ratio. It is also helped out by the excess leads that come from the solution, because the leads which come out of arms 1 and 2 never are added to this pipeline in the bottom. I also like that the quicksilver excess that is delivered for these, because just getting these 2 quicksilvers isn't enough to finish off the inputs that are needed. The quicksilver excess which comes from here is being held by arm 17, and there's a very zippy moment here where it moves from here up through a rotation from this point to this point so it doesn't collide, and delivers a pair of quicksilvers up to this top pipeline. So Penta Pig early on had suggested that using 4 inputs to make an output gives you excess. Using 3 inputs to make an output requires use of some of that excess. And it's very interesting to me to see that this final solution ended up like this, which is a very unique approach where 4 inputs to make an output happens, and then that pipeline just pauses. And during that pause, arm 12 has to deliver a quicksilver, which is how these are formed, these bonded pairs. And so arm 16, that is generally just a rotate, pivot, drop arm, has this little shift to the side to get out of arm 12's way. And I kind of think of that as a funny feature of the solution, that the pauses are a dance for arm 16. It's doing its work, it's got to dance. So yeah, 17 outputs coming from the bottom via a pipeline that can produce 20 but has to pause. And then 4 outputs created at the top is another way to make 21. This is maximum throughput at 885 gold, and it is a very good solution. Good job, Penta Pig. However, this, as far as placements go, Penta Pig has been towards the top of nearly every category. This is his worst finish so far, but that says something about how extremely good of an optimizer Penta Pig is. There are still 4 more solutions that beat him, and my own, which was non-scoring, so I'll count that as a 5th solution. Brooke has a 835, and I like the title of this one. It's The Copper Swapper. So Brooke definitely embraces the 6 arms in terms of how they assemble the inputs. I found this a rather hard solution to digest, personally. So there's clearly a create and output every 16 cycles pipeline going on right here. And this is the kind of pipeline that has copper excess, and that copper excess is being very clearly delivered outwards by arm 11. So this part of it I understand. And so when things are being fed to arm 17 at this location, once every 16 cycles, this resembles a pipeline that I used in my solution, the 1 every 16. When you're using a 1 every 16, there has to be 11 outputs delivered by other mechanisms. I am not altogether certain how those other mechanisms actually math out in Brookie's solution. So the coppers that are being used as excess reliably turn into an extra silver and almost always turn into an extra gold. But there is one point when it is not an extra gold. And I'm not entirely sure why the feed rates given ARM 12's programming don't cause it to just always be a silver or always be a gold. I don't see what the difference is that causes... Is it every 5th one to have a silver here instead of a gold? There's 2 golds, 3 golds, 4 golds, 5 golds, 6 golds. So is it 1 every 7? That doesn't even work in the 160 ratio. It must be an irregular number. It's not always 1 every n that turns into a silver dropped off at this point instead of gold. But regardless, when it is a silver, there is always an extra quicksilver somewhere to meet it. And it's honestly, to me, this solution is somewhat of a miracle, and I don't know that I'm going to take all the time needed to understand it. I encourage Brookie to give a nice explanation on what they did here. What we can do is count how many times copper is purified. Oh, the aperiodicity comes from the fact that 11 doesn't always drop it off for 12 to handle. It sometimes drops it off into this glyph. I didn't look closely enough, but 11 has two different drop-off points, one in range of arm 12, one on this glyph. When it drops it off to the glyph, it changes how arm 12 is able to handle it. Sometimes that causes a silver to drop out here instead of gold. But all copper purifications, yes, happen on this glyph. And if we look at arm 15's programming, we can probably get a sense of how often that happens. 3, 6, 9, 12, 13, 14. This is 18 cycles gap. And then there's this weird, okay, arm 15's programming is not as illuminating as I had thought. That sucks. But I can trust that this is still following the 34 to 16 guideline to make sure that it's full throughput, because I can watch 160 cycles pass, 21 outputs are created here. The existence of a disposal glyph is because, similar to Panic's solution, the pipelines aren't always in perfect sync. The very first time that material gets through here, arm 7 isn't dropping anything that is getting absorbed. If Quicksilver is not absorbed, it's actually really neat. The handoff causes it to get passed back to arm 8 and into the disposal. So Quicksilvers that are excess here go up the right half of arm 8, do the entire loop on arm 7, get back onto arm 8, and drop into the disposal. That's only for things which are used when there aren't metals yet on this side of the pipeline, which means it happens a finite number of times. The disposal is not being procced in the infinite limit, and so you have full throughput despite the disposal existing and being used more than once. Yeah, Brookie's solution. Brookie was another person who spent a lot of time sending me DMs over the week to help work out the math, and they're the person who created a very cheap every 8 solution that threw away all the lead before realizing, you know, the lead is being thrown away and it can be used. I just have to swap it out for Quicksilvers. They did the math, they figured out optimum throughput, and then they created this enigma of a solution. I don't understand the Left's pipeline enough to be able to talk about it. But it's at 835 gold, so that's an extremely good showing. It was beaten by 5 gold by Jinyu. Jinyu's solution uses a tactic that is in the cost-optimized maximum speed refined gold, no, purified gold, the slightly more trivial, non-trivial one, where a single arm on a track is holding something on both of its grabbers and translating it in a direction. So Jinyu's process looks like an odd one out pipeline as well. The contract being held is that there is a gold traveling to this location every 4, half the time it's passed to the right, and half the time it's dropped here to finish off an output. Jinyu told me that the placement of the disposal here was just for decoration because this entire hexagon is being used anyway when arm 8 is swinging. So the fact that you can fit the disposal glyph in this and have it really, none of these hexes are used for anything other than swinging through. He thought of it as artistic, and it's cool. So the odd one out pipeline is coming from handling over here on the left. The excess leads are being purified all the way to silver. Is that a general rule, or are they ever being moved out as copper? Nope, excess leads are always becoming silver. Silver is taking the place of a copper in this pipeline occasionally to prevent the use of one Quicksilver, which again earns a Quicksilver for this odd one out pipeline. And so ARM 24 gets to play the low-cost solution game where it gets a really, really slow feed of atoms and is responsible for building up this solution from them. Jinyu, in his classic fashion, is extremely good at optimizing a good idea and came up with a very good idea for the solution. So, good job, Jinyu. The next solution that I want to look at is my own. So I used the same approach as Mr. Puzzle used, where there's 3 pipelines going on. And this solution, because I created it quite a while ago, well before the puzzle was released because I'm the host, I modified it slightly since the GIF that I created for it. Right now there's a disposal here to handle, similar to Brookie's solution, some Quicksilver that I know won't ever make it into a purification process. or projection process. But I can talk about the solution a lot because I understand it because I made it. So ARM1 here is feeding the copper into this pipeline that's going to ultimately create an output every 16 cycles here that ARM8 delivers. There is excess copper, and ARM5 is handling it as it delivers every other copper to here. It delivers other coppers into this purification glyph. Sometimes ARM19 gets to be the decider of whether they make it into the purification or not. So ARM19 is responsible for grabbing the silver off of the purification end or grabbing a copper here to prevent it. So ARM5 stalls at this point, allowing this copper to be grabbed, and ARM19 takes it away. It is at that point functionally identical to having grabbed a silver here, except that it sucks up 4 quicksilvers from this the buffer that ARM18 is serving at, instead of the 3 that a silver would suck up. So it'll take a silver and use that to eat 3 quicksilvers, 3 more, and then a copper and use that to eat 4 quicksilvers. So every 10 quicksilvers that are delivered to ARM18, I generate an extra half of an output. And every 10 comes every 40 cycles, or every 40 inputs. So it works out. This pipeline is generating 3 things every 40 inputs, or 6 every 80 inputs. So here we have one that is creating every 16 cycles, which is 5 every 80 cycles, 10 every 80 inputs. So 10 plus 6 plus 5. The 5 on the left is going at just half the speed of this one effectively, because the metals that are being provided are half the value. It creates the extra quicksilver for this because of the fact that it ends up generating too much quicksilver. But after purifying all the way up to copper, meaning there are 4 quicksilvers left to use, it projects twice, bonds twice, and delivers over to here, where ARM17 is able to help finish off the output. ARM21 does the nice job of this that produces 5 outputs per 160, and this that produces 6 outputs per 160. ARM21 does the balancing job of delivering all 11 outputs, and since they're coming in at just barely different rates, there are a few points where it has to do some dodging to compensate for that. And neither of those outputs are going to conflict with the outputs from ARM8. So this is my own solution to the how do you deliver everything to the final pipeline to the output. And again, because you have a few arms and lots of cycles to play with, it's generally easy to avoid making things crash. The hardest part is finding out a full throughput approach that will make sure that you're generating all the metals. And this takes 800 gold, and I thought this wouldn't be beaten. I didn't even think it would be tied. So when I saw Alerka submit their solution and it improved gradually all the way down to 800 cost, I got tied. So Alerka managed to tie me exactly, and this earned Alerka second place. What I really like about Alerka's solution is that there is a single projection glyph in the entire solution. They spend a lot more on arms than I do, but they are very minimal in terms of expenditure on glyphs. There's a single multi-bonder for the main pipeline and a single bonder for the odd one out pipeline. Both sides obviously have to handle a debonder. Oh, there's a bonder here to help feed the pairs instead of just single atoms. But apart from that, there's the few purification glyphs and the single projection glyph, which just blows my mind. And the reason that they're able to use a single projection glyph is that the excess part, when they swap in a copper, they let this sit here until the excess is gold. So it's always the same. The gold is being created in the exact same place, regardless of whether it's being created for the odd one out pipeline or for the standard pipeline. The way that the excess quicksilvers are earned, in effect, is that this track loop of arms sometimes will do that. Instead of delivering it to this output, or to this projection glyph, it spins it up and bonds it to the existing gold that it had just earned. And because the metal that is being put onto this side is a silver instead of a copper, the absence of one of these quicksilver is not important and in fact doesn't impact the solution at all. So every time that generates a copper, it uses that purification to supplant one of the quicksilvers, get it out here, and add to the odd one out pipeline. Sometimes it also has an excess gold that is created because of having two silvers available and feeding them on adjacent cycles on the same projection glyph. One of the golds joins the main pipeline, the other gold is sent up here to be part of ARM12's low-cost ring building. I think the solution is fundamentally amazing in terms of how minimal its usage is of glyphs. Unfortunately, some of these, the approach that will feed the atoms into the initial purification glyph and the approach that liberates this quicksilver, they both take a lot of arms. There's hefty track loops with plenty of arms on them. Alarico remarked after seeing the winning solution that they were able to turn this solution down to 755, which is a big improvement, but it still is mind-blowing to me that the actual winning cost by Rolomny was 700 even. This is a maximum throughput solution at only 700 gold. It is an auto-and-out pipeline. It uses two 3-arm track loops to start the process of filling a purification glyph. And that causes the period in terms of instruction count to be 480 instead of 160. But the analysis of this solution by Jinyu is that this is well worth the complexity of a track loop, because it can solve this problem and effectively provide an every 2 cycle quicksilver source on this tile and on this tile down here, and an every 4 cycle metal source on these 2 tiles without any extra machinery. It takes the input, the debonder, a 3-arm track loop, and a purification glyph. Repeating that motif twice is the most effective way of starting the solution. So Rolomny is off to a very good start. Now how does he actually solve the process of getting the out-one-out pipeline completed? So we can see already that there's an extra quicksilver at some point, and that quicksilver has to be fed back into the machine. What seems to be happening is that extra coppers coming out of this line always become silvers. Extra silvers become golds, with a single quicksilver that is grabbed by ARM13, prevented from traveling to this side, instead travels to this side. And when that happens, an extra copper is snatched off from this side because there's no metal on this at all. Similar to Peen Locket, it's delivering outputs missing a gold. ARM16 is in the exact right position to take this metal, which was formed out by this pipeline, and put it where ARM8 was already going to be using it, join it in, make those last 2 bonds, and ARM8 gets to be agnostic to whether the handling it is doing is on a completed product or a product that is yet to be completed until the gold lands here. So, how to understand how often to put a gold here, how often to make an incomplete product versus how often to keep it a complete product. Well, we need excess copper, and so we should look at how often ARM14 is working, because ARM14 is handling excess copper. So here's one, it has 6 cycles on and 10 cycles off. So every 16 cycles throughout? No, not throughout. 4, 5, 6. It looks like 6 times with a 16 cycle gap per 160 cycles of solution. So copper is being taken from the right half of the solution 6 times per 160 cycles, and accordingly 6 of the 20 outputs being produced by the main pipeline need to have a gold supplied by the left pipeline. When a copper is delivered, it is used to help purify a silver, which it projects into a gold, which it immediately makes into this. So when a copper is freed, it eats from this left pipeline a purified copper, a liberated quicksilver, and it makes the gold. But the absence of a copper doesn't just liberate one quicksilver, it liberates a second quicksilver too. So every time a copper is used, this solution gains 1 quicksilver on its left pipeline. That makes total sense because it then uses silvers that it creates on its own to finish off the 2 metals and adds the 6 quicksilver to produce an auto-and-out ring. So it makes it's the exact same approach which is being used by a few of the other auto-and-out pipelines, where by generating 6 extra quicksilver and then creating a few extra coppers effectively organically, it can make this extra output every 160 cycles. So the swappy action on this is done very subtly. The fact that it is allowing our mate to be conditionally agnostic to the fact that there is a missing gold on its output, and the fact that everything is just in the right place at the right time. It's a very slick solution. It takes a redesign to be able to make something like this. I can imagine, like Rolomni sent me his first solution and it was in the 1100s of cost. Redesigning, knowing what you're going for after creating a first solution, all in a 10-day time span, shows that Rolomni really gets this game, and I love that. The fact that so many of the pieces that need to be accessible to an arm are at positions that a length 3-arm can swing here to here to here, and nothing will collide, and it'll put the thing where it needs to go, without extra tracks, without extra cost added. This solution, I wouldn't go as far as to call it perfect, but this is a mind-blowing solution, and the fact that it wins this category is extremely well-deserved. Very good job, Rolomni. Now, I think I got probably a little more long-winded than I intended to be on the throughput solutions because these are complex machines, but I think it was time well spent. Hopefully anyone who understands their own solution better than I was able to explain it would be willing to add some commentary, whether in the comments of this YouTube video or their own video. But I thank all the participants this week and all of the wonderful throughput solutions I received. This was a fun category for me to create, and I was very happily surprised how many people endeavored to complete max throughput and do a very good job with it. At this point, my voice is starting to fail me, so I'm going to say goodbye, but keep on the lookout for week 3. And anyone who is interested in participating and hasn't started participating yet, it's ongoing, and you don't have to have any prior commitment to join in. There's week 4 has recently been released. You can find it on the Reddit, you can find it on the Discord, you can find it on the Steam forums. I'm trying to make sure that it doesn't require you to be in one particular version of social media to be able to participate in this tournament. As long as you're able to get me a solution file one way or another, I will include it in these videos once you have submitted it, once I've scored it, and once we know what the deadline and the scores are. So on that note, thanks for watching and goodbye.